There we go. Now we got it. Hello, 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 everybody. How's everybody doing today? This fine evening. Hopefully, everybody is doing fantastic. All right. Welcome, welcome, everybody. How we doing today? Hey, make me proud. Hello, hello. You doing good this fine evening? Hope so. How, yes, good. Hopefully, plans for the weekend a little bit. Get a chance to relax. Hello, Strolling. Strolling, I tried to connect with you via Discord and I couldn't. Did you get your my math lab stuff fixed there? I tried calling you or tried leaving you a message in the Discord and okay. Were you able to do the my math lab stuff? Because you said you had issues about that too. Okay, good. All right. I just wanted to be able to follow up because I didn't hear back from you. I was like, oh, I tried to contact you like 3 different ways. I'm like, man, it's so hard to get in contact with you. I couldn't connect with you on. Okay, all right. I guess. Well, I'm glad at least that the issues were fixed. So at the very least, that's perfectly fine. Again, apologies. Email me if you have issues. Then email me or again contact me via Discord. Maybe we can get that to work out the next time another issue pops up. So today'll be a nice day. I think today is a nice day, so should be relatively easy today. So should be some easy peasy lemon the squeezy today. At least I think so. And that's what I think. Is that what I know? I don't know. But we're gonna try anyway. Ha ha ha. All right. We're gonna get started here in just a minute or two. I know I started the stream here just a bit late, so I'll wait for a couple more minutes here. We'll have people start to hopefully flood in here, and we'll get started with today's sections. All right, and then I'll be making some announcements here at the end of class, so please stick around to the end here today. We'll be talking about a couple of important things. All right, so we will definitely talk about that, and got some information for you. Right. Oh, good. We got a few more people coming in. Good, good, good. Hello, Julia. How are you? How we doing today, Julia? Hopefully we're doing fantastic. Are we on this fine evening? All right, we'll get started here in just a moment. Excited for the weekend? Hey, sound like you got some plans for the weekend there. That's good to hear. Sounds like you got a lot to do. Ha ha ho. Always. always has plans. I'm gonna do this, and I'm gonna do. All right, let's get going here, ladies and gentlemen. All right, minute has passed. Let's do this. All right, let's get some intros going. Let's get started with some of this material. Get moving here. All right, we'll get it done. All right, let's do this. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, ladies and gentlemen, today we're going to pick up where we left off last time. Last time, we talked about sample standard deviation. We talked about population standard deviation. Use the calculator to go ahead and do that sort of stuff. All right, and so today we're going to be finishing off the rest of Chapter 3. But just as a reminder here, before we get started here, we are skipping a section. All right, we are skipping section 3.3. Okay, so section 3.3 will not be appearing as a homework assignment or on the test or anything of that matter. So anything we skip, as you know, will not be reflected on the exam or on the homework. So there should be no section 3.3 for your test or homework otherwise. So again, not going to be talking about that, and you will not see that whatsoever. So that means what we are going to be doing here today is we're going to be skipping over to section 3.4 and 3.5, which are the last couple of sections here in chapter 3 instead. All right, so let's go ahead and bust out the handout here, and we're going to go ahead and take a look here at the always amazing big board, and let's see what questions that we do need to answer here in section 3.3 or 3.4 and 3.5. All right. So we're going to be starting here from the handout. Now the handout here, we're going to start here from this third question. Okay, so again, we talked about sample standard deviation. We talked about population standard deviation. Now we are also going to talk about another concept here that's kind of thrown in here in chapter 3, but it does have implications here later on into future content. All right, so especially for future sections, we will be looking at this in a little bit more detail, but they do introduce it here in this section, so we'll talk about it right now. And that talks about the idea of a z-score. So let's talk about that here in this instance. So what exactly is a z-score? How do we find a z-score? Well, first of all, let's talk about its appropriate definition. The definition of a z-score is this represents the number of standard deviations a data item is away from the mean. Okay, so we can find out, we take a data item, we figure out, well, how far away, how many standard deviations it is away from the mean if we're given a mean and standard deviation, and that's essentially what it's going to tell us. So we have this formula here that's written here for z-score. It says z-score here take the data item, we subtract it from the mean, and we divide it by the standard deviation. And that's going to get our z-score here at the end of the day. Now, I put a few notes here that are going to be important here when we talk about z-score here. First and foremost, it is perfectly okay to get a negative z-score. Why is that? Well, not only does the formula allow you to have a negative value, but another thing is a negative value, a negative z-score, would reflect that that data item is to the left of the mean. It would be smaller than the mean, for example, if we're putting stuff here in numerical order. All right, so again, if we had a positive z-score, that means that number here would be to the right of the mean or higher than the actual mean given for the entirety of the data set. The notation here is given as z. You will see that often here using z or z of the data item. If we're using a specific data item, then you'll see that as well. And then finally, the other thing about z-score that I wanted to make a note of is that every data item has a unique z-score. Okay, so if each data item is different, because the formula takes into account each individual data item, each one of those z-scores are going to be absolutely different. Again, if you have the same z-score, yeah, they're going to be the same. If you have the same data item, yeah, you're going to have the same z-score. But if they're all different, all the z-scores are going to be different because each one is unique. So let's go ahead and do an example here of z-score. And it's really honestly not that hard to do. But let's go ahead and look at some examples here, just a couple of them. All right. So let's take a mean here. We'll just make up a mean here. We'll call it 32. And let's say the standard deviation here, let's say the standard deviation here is 6, okay? So let's say mean is 32, and a standard deviation here is 6. Okay, so let's take a gander here. Let's say I want to say, well, what is the z-score for the data item of 30? Now, I just randomly made up 30 here, all right? And there's no rhyme, no reason where I came up with 30. But it's just a random data item of 30. So I'm going to use the formula here appropriately. I'm going to take that 30. I'll plug it in terms of the data item. We'll subtract it from the mean of 32. And I'll divide by 6. Now, can anybody tell me here, what is the z-score that we get here for 30? What's the z-score here? Again, if we get a negative number, that's perfectly fine. So can anybody tell me here? Just type that out in the chat. What's the z-score here for 30? A 0.333 repeating. Is that going to be positive or negative, Bill? All right, Make Me Proud says negative. All right, so that's correct. Okay, so we're going to combine both of those answers there together. Yeah, so sign is going to matter here. So just understand, we do want to include the sign here. All right, so 0.333 repeating is correct, but you need to have the negative in front of that. Okay, so z-score, because it has the possibility to be negative, if it's negative, we're going to keep it just like that. Okay, so it won't always default to the positive value. All right. Let's take a good look here at another one. Let's look at let's look at that one there. Let's look at 42. Let's say I've looked at 42, and I want to find the z-score associated with the data item of 42. Okay. So what should I do here in this case? 42 minus 32 divided by 6. 6.5. 6.5. Hey. Kind of an odd answer. 1.6667. Okay, good. I get worried there. I'm like, whoa, what did I do? So 1. Let's do 667. All right. Okay, so as you can see here, we got a z-score here of 1.667. Fine. So there we go. It's just that easy, just that simple, just that fast to find a z-score. So essentially, how could you read this off here verbally? You could read this off as like saying, okay, well, z30, for example, says the data item of 30 is negative 0.33 standard deviations away from the mean. You could say the data item of 42 is 1.6667 standard deviations away from the mean. Okay, so again, you can kind of verbalize like that. You can consider negative to be below. You can see positive to be above. Whatever you want at the end of the day. Negative 0.33 would be like negative be 0.33 standard deviations below the mean. I want to say like. All right. In any case, the question really becomes is we have these z-scores here, and that's all well and good. The question is, what are we going to do with some of these z-scores here? Now, we're not going to expand on this too much here in this section, but what is important is one thing that you can link z-scores to. That is the next question that you see here on the handout, which is talking about percentiles. So exactly what does percentile mean here in statistics? So basically, that's going to be the data item that is k% better than all other data items in the data set. Okay, so the data item that is k% better than all other data items in the data set. Okay. You're probably wondering, what the heck does that even mean? What are you talking about? Well, let's use a practical example here. All right, so I'm just going to ask a question in chat here. I won't poll this because there's not a lot of people, but you guys can answer it however you wish. All right, So let me just get a quick poll from people here. Have you ever taken the ACT, the SAT, both of them, or neither? And it's fine if you've taken some, if you've taken one, if you've taken the other, if you've neither done. I don't care either way, so that's fine. The SAT, you can use Sammy. All right. All right. Anybody else wanna? You take neither? That's fine. Hey, look, some people haven't taken either, so you know that's perfectly acceptable. I mean, when I wanted to enter college, I had to take a full disclosure for you guys. I took the ACT myself. I never did take the SAT. I was told like more, some colleges interchange between the two now about what's acceptable for admissions and whatnot. Now, I don't know what you guys have gotten here, but if you do take an ACT or SAT test, or maybe you've taken a more of a public test, maybe you took an AP test or something like that, whatever the case may be. My point is that usually when you do one of those type of tests, or even do both, typically you get something in your email, or you get something in your mail discussing the results that you got on the test. Now, in the ACT and SAT, both have 4 sections. They have like a reading section, a math section, like some kind of I forget the other 2 sections off the top of my head, like something science section or whatever. I don't remember. I'm bad at that. In any case, you have 4 sections that you have to answer questions over, and each one of the sections have a requisite amount of points. So, for example, here, ACT has 36 points for each section, so the maximum score that you can get is a 36 on the ACT. If you average a 36, meaning you got a perfect score. So, so the way it works is that they'll tell you what you got. They'll break down each score here. It's like, oh, you got this amount in the reading section points, you got this amount in the math section, you got this amount in the English. Okay, so whatever you want. Now, what they'll also put in those score reports is not just the actual score that you got on this section, but they'll also compare you to people who took that same exact test. So, for example, if let's say I scored really well in the math portion of the ACT test, let's say I scored really good, and they say, well, you are in the 90th percentile of people who took this test. That means that if I'm in the 90th percentile, that means that I did better than 90% of the people who took that same exact test. Okay, if I did really really good, let's say I did really really good, I did outstanding, I got close to a 36. Maybe I'm in the 99th percentile of students who took that same exact test, meaning, say, again, I did better than 99% of students who did that same exact exam. So in statistics, it works exactly the same way with the data item. If I say a data item is K% better, I could say, well, a data item is in the, 80th percentile, meaning that data item is bigger than 80% of the data items in the data set. Essentially, that's basically what it boils down to when we talk about percentiles. And what's the importance of percentiles here? Percentiles, what we want to do here and what we'll see later on in future chapters, is we're going to link the idea of a z-score over to a percentile. So we want to use a z-score as kind of like a medium to kind of understand where a data item would fit in the overall broad picture of a data set in terms of its percentile and where it would be located. And this is especially helpful with thousands and thousands of numbers as opposed to a small amount. So it makes it significantly easier to look at. So we will be looking at that kind of relationship later on. However, what we will be using percentile here in this chapter anyway is looking at it from a more basic perspective here. But like I said, this is a concept that you are going to be seeing later on, and of course in this chapter as well. Before we move on here, are there any questions about that before we move forward? Any questions? And type no in the chat if you have no questions. Or again, if you do have a question, please type it out as well. Okay, gonna go ahead and move forward then. All right, so yeah, so question 1 and question 2 are related to section 3.3, so we're skipping those, strolling. So that's for section 3.3, and for this class, we're skipping section 3.3. So you can just put a big old X in those two questions. Those will have nothing to do with what we're doing here for this course. So you don't have to worry about that part, okay? All right. I'll always tell you if we're skipping stuff, so I just want to let you know. I'll always tell you if you're skipping stuff. All right, let's take a good look here at question 5. Let's look at question 5 here. Now, question 5 asks, what are quartiles? What are quartiles? So, quartiles are where we are going to be using percentiles here. Again, we're going to be using percentiles here from looking at a data set from, again, another big picture perspective, only we have much more very hard definitions here for each one. So first of all, the notation here for quartile 1 would be Q1. All right, and that reflects the 25th percentile. Now, it does have the definition next to it, as you see there on the screen. It is the median of the data set that is to the left of the median. All right, we'll talk about what that means because on paper, right now, that looks very confusing. But I assure you, we're going to get to an example which will showcase that off. However, the ones I want to focus on here, of course, are going to be Q2, which is the 50th percentile, Q3, the 75th percentile, Q4, the 100th percentile. Now, as you see here on the screen, Q2 here is the 50th percentile. That we already have a name for. That's the median, right? 50th percentile is dead set right in the middle, and we already know how to find the median. We talked about it previously. So this shouldn't come anything brand new here to find Q2. So we don't actually use the notation of Q2 since we already have another name for it, that being the median. And we don't use Q4 here as notation as either. That's the 100th percentile, i.e. the highest data value in the data set. It's really simple. Just look for the largest number, guys, and then that's Q4. So we don't actually use Q4 here because of how easy it is to find largest data item. It's not hard. Okay, so the two things that we're going to clue in on is we're going to clue in on Q1 and Q3, and we're going to get to how to actually look at those here momentarily. All right. Now, before we go ahead and do that here, we're going to go ahead, and so let me go ahead and talk about what I'm going to do here next, okay? So next what we're going to do is we're going to do our example here, and the next, this example is going to cover the entirety of the rest of the class. So we're going to answer the questions here of 6, 7, 8, and 9, but the way we're going to do it here, just to let you know, is I'm going to go straight to question 9, and then I'm going to come back to these three questions of 6, 7, and 8. So I will come back to 6, 7, and 8. So I'm not skipping 6, 7, and 8, guys. I'm going to come back to that as we go through this process here step by step, as we go ahead and do the main topic here of what we're going to want for these next two sections, which is how to construct a box plot for a data set. So that is going to be question 9. Like I said, we're going to go through each one of those questions 6, 7, and 8. We're just going to go ahead and do it methodically in order, along with the steps about how to construct a box plot here. So let's go ahead and do that here together. All right, and let's see how it works out. All right. So first and foremost here, I'm going to go ahead and put in an example here. So this example is just going to be our regular old rigmarole example. All right, again, using our stem and leaf plot. So I'm just going to make up some numbers here. Okay, so let's take a look at the stem. Four, 5, 2, 3, 7, 8, 9. Okay. Or 7. Just trying to make up some numbers here, guys. Okay.
What if I go stronger? What if I get higher? What if I start doing things I know I will
Okay,
regret?
here we go. All right. So these are the numbers here in our stem and leaf plot that we're going to be using for our example. Okay. So here we got the stems again. 0, 3 represent 3. 0, 8 represent 8. 1, 0 represents 10. You get the general gist. Okay. Now let's go through each one here carefully. Each one of these steps here in order to construct a box plot. I'm gonna go slow here so that way we get every step down and we'll see exactly how to do that. I'll be asking you some questions along the way, just like, well, right now. So let's go over step 1. Okay, so step 1 says, how do we construct a box plot? So the first thing that we have to do is order the data set and find the median. Now, one thing that I can tell you right now is this data set is already in numerical order. So I already went ahead and did that already. So after we order the data set here, we have to find the median. So, can anybody tell me here? What's the first thing that we need to do to find the median after ordering the data set? What's the first thing that we do here? What do we need to do here in order to find the median? We ordered the data set, so we're done with that. I gotta do something before that, Strolling Stones. So you're very close. Total number of data, that has something to do with it. I don't disagree with that, Sanla. But what did we do with the total number of data here? Alright, so this is something that you guys gotta get to know. Alright? Find the position. That's correct. So understand, even and odd is a thing, but you first have to find the position of the median. Like, I agree, even and odd is a thing, but that's the second part of the process. What you need to first do is find the position about where that median is located. Then we take into account even and odd in the process, because then we actually find out how many data items are in the data set. So do keep that in mind, all right? You don't want to be skipping for this one because we will be kind of using this quite a bit here. Does anybody remember how we find the position of the median? What was that formula? How do we find the position of the median? All right, very good. N plus 1 over 2. All right, good. Excellent, excellent. All right, so far so good, guys. All right, good. Now, let's answer this question here. How many data items are in the data set? How many data items are in the data set that you see here on screen? Okay. Very good. Very good. All right, so there are 16 numbers here in the data set. That is correct. So, if we were to do this out, then this is going to equal 16 plus 1 divided by 2. So that's going to be, again, 17 divided by 2. So So that's going to be 8.5. So the thing we want to look for here is we want to look at the 8.5 position. All right. So let's count 8.5 positions here on the data set, and then we're going to find out where exactly that median is located. So let's count. So we go 1, 2, 3, 4, 5, 6, 7, 8. So 8.5 would be right here, right between these two guys. So right where my red arrow is located is going to be the median here in this instance. Okay. So, okay, so we know where the median is located. So can anybody tell me, what do I do next? How do I find my median? We did even or odd then. We did. It was an even amount, so we found it in the 8.5 position. So we have to take that. Now we take that scenario into account, Horitz. So 25, 28 plus 27, 20. Okay, I'm a little confused. Sorry, Strolling. What two numbers is the what do we have to do here, guys? Okay, we're going to take the two numbers around that said position. We'll do 28 plus 27 divided by 2. All right, and so what do we get here, right? We got to take 27 plus 28 divided by 2. Sanala, be careful about that. 26? Really? Oh, Strolling, you're making assumptions. Get 27.5. All right. All right. So Strolling, you got the right process, but the number wasn't there. It should have been 27.5. 27 plus 27. Yeah, just be a little careful about that, Strolling. All right. I guess that's one thing about math you have to be careful about, is don't tunnel vision yourself to one answer. Just make sure you check it again and make sure you got that down. Sometimes you get tripped up on that. It happens to me too, to be fair. So, okay. All right, so here we have the median here of 27.5. All right, fine. All right, easy peasy. Did that just great. All right, any questions so far? Any questions? Okay, so let's move on here to the next part. All right, so let's do step number 2. I'll change the color here for this one. All right, so put it in blue. All right, so step 2, let's look at step 2. Find Q1 and Q3. So we're going to find Q1, the first quartile. We're going to find Q3, the third quartile. Let's talk about it. Let's first talk about Q1. Now I'm going to go up here to question number 6, okay, on the handout, because we're going to need that. Or not question 6, back to question 5, excuse me. Pardon me. Apologies. So let's go back up to question 5 here, because now we're going to actually implement the definition that we have here for Q1. So let's take a look at that one more time. So Q1 here, the 25th percentile, is the median of the data set that is to the left of the median. Now you're probably saying, whoa, time out. That's a lot of words, and you have median twice. That tends to be a little confusing. So this is why I have a picture up here for our example, so you can see exactly how we find Q1 here by hand, and then you can see exactly how we go about doing that here. So if you take a look here on the screen to the right in our example, in our stem and leaf plot, the red arrow indicates exactly where the median would be located in that 8.5 position. Now this is the reason why we wanted to find that first, because now based on the definition here of Q1, it says find the median of the data set that is to the left of the median. So I want to look at all the numbers to the left, okay, all the numbers to the left of that median, not including the median, but all the numbers to the left of that median. So let me circle the numbers here of all the numbers here that are to the left of this red arrow. Circle all these numbers here, just like so. Okay. So these are all the numbers that are to the left of that arrow. Okay. Okay. Now, all we need to do here is to find the median of these numbers right here. That's what we're going to be doing here next. Okay. So what we need to do is, of course, we're going to do the same exact process. We need to find the position of the median, and then we're going to go ahead and find the median here in this case. The only key difference is we're not working over 16 numbers this time. We're now working over a smaller data set, in this case of 8 numbers. So, if you look at the position of the median in this case, that's going to be 8 plus 1 divided by 2. So that's going to be 4.5. So that median there is in the 4.5 position. So I'm going to count 4.5 numbers, and then we're going to see what we get. So we get 1, 2, 3, 4. And in blue, I'm going to mark this in blue. I'll put a blue arrow right here in between these two numbers right here. So if I want to find what Q1 is going to be, I now take the values here of 11 plus 14, and I divide that by 2. And so here I get 12.5. Okay. Before we move on to Q3, are there any questions about how I found Q1? Any questions about that? So let me ask you this question, make me proud. Do you understand how we came up with the 4.5 position? Does that make sense? Let me ask that first and foremost. Okay, so all I did was count 4.5 positions, just like we did with the median. So I counted here 1, 2, 3, 4. And so where this blue arrow is located is where Q1 will be. Q1 here is the median of the left half of the data set, so all the numbers to the left of the median. So that's between the numbers 11 and 14. Remember, 1 and 1 is 11, 1 and 4 is 14. I take the mean of those two numbers, just like I did for 27 and 28. That's where I get the 12.5 from. I'm doing the process no differently than I would approach the median, only now I just have a smaller data set that I'm working over. Yeah, no problem. If it clarifies stuff and helps you understand, that's what it's all about. Okay. Let's take a good look here at any more. Actually, should be okay. Yeah, any more questions? If anybody has any more questions, please feel free to ask. Otherwise, I'm just going to move on to Q3. All right, let's try Q3. Now Q3 is going to be the same, okay, in terms of position. The only difference is actually, yeah, let me do it this way. Sorry, I'm gonna do it this way. I'll put this in a slightly different color so it's a little bit more clear. So again, what's Q3 here? The 75th percentile. It's the median, again, just the opposite here. The median of the data set that's to the right of the median. So median of the data set that's to the right of the median. So again, the median here is this red arrow right here. We're going to pick all the numbers to the right of that red arrow. So we're going to circle all of these in purple. All the numbers that are to the right in this case. All right. So those are all the numbers there to the right of the median. Again, I'm not including the median. I'm just saying all the numbers to the right of that number. Now, one thing that we can say for certainty, again, you have the same amount of numbers to the left, to the right as you do on the left. So the position is going to be exactly the same. It's going to be the 4.5 position. That part there is not going to change in terms of where we're going to find the median. The only thing is that we start here, right here at the 8. So let's count 4.5. So we got 1, 2, 3, 4. And right here is going to be the 4.5 position, just like so. And let's get you guys to help me out here for this one. What is Q3 going to be? What is the median of the right half of this data set? What is Q3 going to be, guys? All right, so the answer here is going to be 35.5. Okay, very good. That is correct, right? So we're going to take that 34, add it to 37, and we'll divide by 2 here. Again, because it's right between those two values, not actually on a value. And so, indeed, we get 35.5. All right, good. So now we've effectively found both Q1 and Q3. All right, any questions about either one of those before we move on to the next step? Just going through this methodically. Okay, let's go ahead and take a look here at the next step. Okay, so we found our median, we found our Q1, we found our Q3, so we're set and ready to go there. Let's go ahead and go to the next step here. I'll put this in a different color. Go ahead and put step number, oh, that's not the color I wanted. I clicked on this color. And all right. Let's do step 3 here. All right, so what's step 3 here? Step 3 is find the IQR. Now, what is the IQR here? IQR stands for interquartile range. And that it comes back over here to question number 6. So let's look at question 6 here. It says, I need to find the IQR. Well, what is the IQR? It's a very simple definition. The IQR here is taking the Q3 we just found and subtracting off the Q1 we also found in that same step. So Q3 minus Q1, all right, is the IQR. Now, you're going to see me do this quite often in a lot of different of these processes. Is I like to do things out step by step. It's a pretty common thing that I do. The one thing I want to say here is that I like, especially, sometimes you'll see me do this as like, hey, this is a separate step than that of the rest of the process. That's because I think sometimes, you know, I don't want to do two things at the same time all the time in the same step if it's not that necessary. Okay, so like step 2 with Q1 and Q3, you can do those at the same time because they have similar definitions. But IQR says, let's say you make a mistake for some reason, it's easy to see in a separate step than it is kind of all smushed together all at once. So you'll see me do that quite often. It's like, it seems like when you first see it, you're like, oh, that seems kind of pointless. But in reality, I like to break things down, one at a time, where I feel it to be necessary or important. IQR is certainly there in this process. Up there in this process. So why is IQR here important? Well, let's see. Q3, we'll take Q3, which is 35.5. So it's really easy, but again, want to be sure we're not making mistakes in the middle of the process. So minus 12.5, which was Q1. So if we take 35.5 minus 12.5, we're going to get a granddaddy total of 23. All right. So 23 here will be your interquartile range. Very easy and very straightforward to do. All right. Let's move on here to the next one, though, because that is, you need to be a little careful about that. So let's look at that. So once we found the interquartile range, the real question is, what are we going to do with it? Okay, well, that's where the next step is going to come into play. Step 4. Step 4 says to find the lower and upper outlier boundaries. So we're going to find the lower and upper outlier boundaries. And so this is where the next question in the handout is going to come into play, which is question number 7. I'll quickly scroll up here. So number 7, what are the outlier boundaries? So we do have two formulas here in this case. First, the lower outlier boundary, which we'll label as LOB for short, is going to be equivalent to Q1 minus the 1.5 times IQR. Then we have the upper outlier boundary, which is going to be equal to Q3 plus 1.5 times IQR. Now, one thing I want to point out here that is very important is please note the difference. So one common mistake is people don't note the difference between both of these formulas, as there are major differences. Let's talk about the two major differences in between both of these formulas. First one, the lower outlier boundary contains Q1. Okay, it uses Q1, not Q3, it uses Q1. Whereas the upper outlier boundary uses Q3. So lower uses the first quartile Q1, but the upper outlier boundary uses Q3. Remember, you are not using the same quartile in either one of these particular formulas. The second difference here is where the lower outlier boundary here uses Q1 minus. It has a subtraction, whereas the second one here for upper outlier boundary is Q3 plus, okay? And that's pretty important. The only thing that stays the same here is you have 1.5 times IQR. That's the only same that you got there. But outside of that, please note the differences so you don't trip up on those guys right there. All right. So we have that. That's good. All right. So let's take a gander here at lower outlier boundary. All right. So again, that's going to be Q1 minus 1.5 times IQR. Okay. So what is Q1 here? Let's go back to Q1. Again, this is why we go ahead and find this stuff here. So we take 12 and a half, 12.5. We'll subtract it by 1.5 times, what we have here, 23. Okay. And what do we get here if we take 12.5 minus 1.5 times 23? Now, if you do get a negative answer here, that's perfectly fine here. That's not a big deal. All right, so if you do get a minus answer here, you do get a negative answer, no problem here, okay? That's perfectly okay. So Make Me Proud says minus 22. Is that the correct answer here? Yeah, minus 22? Okay. Yeah, negative. So yeah, don't worry if you got minus answers. That's not a problem, guys. Not a problem. That is perfectly acceptable here. That is exactly what we want to have happen here. Just going to follow the process through. That's what we got here. All right. So we got our lower outlier boundary here of minus 22. Fair enough. Let's take a good look here at our upper outlier boundary, and let's see what we get for that guy. Again, now we're taking Q3 plus 1.5 times IQR. So again, Q3 here, we can use the previous, again, 35.5. Plus 1.5 times 23. And what do we get here in this case? 35.5 plus 1.5 times 23. We get 70? Okay. Yeah, guys, I honestly don't even know the answers. You guys just pretty much tell it to me. I make the numbers up as I go along, so. All right. So 70 is what we get here for our upper outlier boundary. Good. All right. Seems fair to me. Okay. So we're going to come back and use these here momentarily. All right. But again, keep these in your back pocket. We're going to come back and use them here once we start putting stuff together. Okay. All right. Questions about that before we move forward? Any questions? No? All right. Step 1 and step 2 are the toughest 2 steps, but that's why we do it in a visual sense, because if you see things visually make me proud, it makes it significantly easier to see. So we want to try and do it just from a visual point of view. And again, if you know where to put the things, it's like, okay, you know, it's like the arrow goes here. All right, let's look at the data set. Let's find the median to that. It's not as bad as it may seem, but again, that's the toughest part of the process, in my opinion. Okay, now to make me proud's other point here, let's do the other part here that's not as stressful, but again, you're probably wondering, says, well, we're constructing a box plot. We haven't even drawn anything out. I'd be like, you know what? That's fair to say. So let's go ahead and go to the next step here, and let's start drawing things out, because I think that sounds like a brilliant plan. Okay. Put this in red again. Actually, I'll put this in blue. So step 5. Go ahead and read off step 5 here together. Okay, so step 5 here says on a number line, we're going to draw a vertical line on Q1, the median, and Q3, and connect them together as a box. Okay, so at the end of the day, we're going to have a number line, and we're going to have a box that kind of floats above that number line. And we're going to see what we get here for our, we're going to put vertical lines here specifically on Q1, the median, and Q3. So the first 3 things that we found, I'm going to use those once again right away. You'll see why, again, why steps 1 and 2 are so important, because they pretty much are the crux of the entire problem. So let's make up a number line here. All right, and I'm just going to follow my data set here. So let's go by 5s. All right, so our lowest number here is like 3 and the highest 55. So let's just go by 5s. Again, this is like a approximation. Not building rockets here. Not calling rocket science. So, you know. At 35 and 40. 5 and 50. And finally 55. Okay. So let's draw in some vertical lines at, again, the median, Q1, and Q3. So let's look at the median here. The median here is at 27.5. That's what we found here in the very first step. Let's go down let's try and find 27.5 right between 25 and 30. I'm just going to draw a line about here-ish. So I'll just label this as 27.5. Okay, so that's the first vertical line to represent the median. Let's now draw vertical lines here to represent Q1 and Q3. So Q1 here is going to be 12.5. So let's go ahead and put in 12.5 right between 10 and 15. So right about there-ish. Again, since I'm drawing it by hand, it's all an approximation. Okay. And let's go ahead and draw in one more vertical line for Q3, which let's check it one more time. Q3 was 35.5. So 35.5 is roughly about here-ish. Right, a smidge to the right of 35, sorry. And all we're going to do here, simply put, all right, very simple, is we're just going to connect these vertical lines into a box, just like so. Bam. And wha-bam. All right, so here's our box, just like so. Okay, hopefully that's pretty straightforward there. Any questions about that part? Okay. Okay, now we're not quite done just yet. We have a little bit more to go. We got one more big step to do. And we have a minor thing to do. But let's talk about that here really quick. Okay, so that's step 5. We've went ahead and made the box part here of the box plot. Might be a silly question, but does it matter if the box is on the top or the bottom of the number line? You mean below it? Are you talking like if the I'm a little confused, Horitz. If this box was like below this, like right here, if that's what you're referring to, like if it's below it, then it doesn't matter, as long as you understand where these lines actually are on the number line, then that's fine. Most boxes will be on the top here, so just like what you see here on the screen. But yeah, if you put it below and those lines represent the same values, then yeah, it doesn't matter. So yeah, it's not a big deal. I'm just going off of like the conventional way of writing it, so that way it's like if you see it again, then you're like, oh, okay, I recognize what that is, or it's represented. But yeah, you're not wrong. Okay, now let's talk about the last part here. Let's talk about the last part here of the box plot, because we're still not quite done just yet. What we need to do next is to draw some whiskers. Okay, so what whiskers are basically in this case is we're going to draw one here to the left and one here to the right. Okay, so we're going to have a left whisker, we're going to have a right whisker. Okay, that's how it's going to go. Now I'm going to read this off carefully here. I'm going to talk about how to draw in these respective whiskers. All right, so hey Dylan, how we doing, my friend? All right. So for the left whisker, we're going to draw the whisker to the next data item in the data set, which is bigger than or equal to the lower outlier boundary. So this is the part where we're actually going to use step 4 here. We're actually going to use our lower outlier boundary and our upper outlier boundary, okay? Let's read that one more time. We're going to draw the whiskers for the left whisker. We're going to draw the whisker to the next data item in the data set, which is bigger than or equal to the lower outlier boundary. Now, let's look at this objectively here, okay? Because it looks very confusing. But let me ask you this question, and then you'll see exactly how this works. let's look at our lower outlier boundary. Our lower outlier boundary as a number is minus 22. Okay? Now, what we need to go, when we need to go off of is that, and this is why I put this in big capital letters, is what we want to draw our whisker to the next data item in the data set that is bigger than or equal to minus 22. So taking a look here in the data set, I put the data set up here. Here's the data set right here on screen. What is the next data item in this data set? It has to be a data item in the data set that is bigger than or equal to minus 22. Can you guys tell me here? All right, Strolling says 3. What else do you guys think? Is it 3 or no? I am Dylan. I'm hoping you have a lovely time. You know you're always welcome here, Dylan. Anytime, my friend, anytime. They're all bigger than minus 22. Okay, that's true. But look carefully, Sanla. This is why I want you to get into the right kind of frame of mind here. I just want the next data item in the data set. So I agree with you, Sanla, that all of them are bigger than minus 22. But the next one, not just all of them, but the next one. Strolling, keep your original answer, okay? You were fine the first time, okay? Okay, good. Okay, so the answer here is indeed 3. No, that's okay. All is forgiven. All right, so the answer here is indeed 3. 3 is the next data item in the data set that is bigger than or equal to the lower outlier boundary. That is the next data item in the data set up above minus 22. So we're going to draw our left whisker here, starting from here. I'm going to draw that out to 3 out here. And I'll label this as 3, just like so. Okay? Before I move forward here, are there any questions about that? I want to make sure that this makes sense. Alright, a little confused here. Okay. So look very carefully here, make me proud. Okay? Our lower outlier boundary here is minus 22. What I'm telling you here, and this is where you have to read this very carefully, is that I'm going to draw the whisker to the next data item. So it has to be a data item in the data set. That's one thing. That's the first thing that it has to be. And it's the next one. So the next data item in the data set. So again, one thing I don't want you to do here, make me proud, is you're not drawing the actual whisker out to minus 22. The lower and upper outlier boundaries here are going to be used as reference values, but they are not going to be places where you're going to be drawing the whiskers out to necessarily. That's why I put the definition as such. So again, if you say what's the next data item in the data set that's bigger than or equal to the lower outlier boundary. Okay, fair enough. Well, you have minus 22 as your lower outlier boundary, right? Make me proud? Well, what's the next biggest number that you see in the data set? If you have minus 22 down here, and if you have to draw it to a data item in the data set, what's the next one up? Answer that, make me proud. Wouldn't that be 3? Right, because if you wrote it in numerical order, minus 22 is all the way out here. Well, no, make me proud. Look at this. Minus 22 is all the way out here. Again, I'm just using it as a reference value. So what you need to wrap your head around here is you're looking at the next data item in the data set. It has to be one of these numbers here of our original problem. So you need to take away the guessing here. You're trying to think of what's bigger than minus 22. I'm looking at things in numerical order. If I said I have minus 22 and I have everything in the data set like so, Here's the data set here. And then I have all the, what's the first number after minus 22? Well, the first number in numerical order would be 3. Because then after 3, you would have 8 and 10 and 11 and all that stuff. But the number that I'm going to look for is 3. That's the next one up, if I were to look at things in numerical order. So I say if that, yeah, so if I say, yeah, exactly. So if I say that's bigger than or equal to minus 22, I said, okay, well, I don't have a minus 22 in my data set. The next one up's got to be 3. Okay. That's what I'm working off of. All right? I'm glad that makes sense now. Now let me see here, make me proud. All right? And everyone else. So let's try it and look at it from the other point of view. Let's look at it from the right whisker now. Okay, so hopefully this idea, this kind of perspective here, I want you to you're going to make sense of it, because now when we do the right whisker, it'll make a whole lot more sense now. So let's go to the right whisker and then see if we got it here. Okay, so for the right whisker, we're going to draw the whisker to the next data item in the data set that is smaller than or equal to the upper outlier boundary. So things are reversed a little bit. So now we're looking at the upper outlier boundary. Okay, now the upper outlier boundary here, as you can see right on the screen, is 70. What's the next data item in the data set that is smaller than or equal to 70, according to this data set? Or it says 55. Everybody says 55 here. All right, make me proud. Would you say 55? Or would you say something different? I want to know. Again, the next data item in the data set. 55, Lil. But do you understand why it's 55 here, make me proud? More importantly, that's the more important part here. You understand why it's 55? Because that's why, that's what I want to be looking at here. Are there any questions about why it's 55? 55 is the correct answer. Kinda yes? Tell me what kinda means. What seems to be the issue then? So you're looking at it this way. I'm looking at 70 is out here. That's my upper outlier boundary. What's the next one below 70 that has to be in my below 70 here? Well, below 70 is going to be 55. So that's the one I'm cluing in on. And then here I get 46 and all those guys. So what's the next one below 70? Well, the next one below 70 is 55. I don't want to overthink it. That's fair. Okay. So we're going to draw this line here out to 55. Okay. All right. Let me slow things down here just a little bit more. Are there any questions about that? Any questions at all about that? I want to be sure everybody understands how those whiskers work. Any questions about that? As I said before, the boundaries are used as reference values, but you don't actually draw the whiskers out to them. Purely based on, you always draw a number out to a data item in the data. Okay. All right. Now, another thing that does happen here is, let's talk about this note I put here. Looking at the stem and leaf table, one can deduce the lower out the LOB and the UOB. It would have to depend on, again, the lower outlier boundary and upper outlier boundary are dependent on the interquartile range and what Q1 and Q3. So you can probably determine Q1 and Q3 at the stem and leaf table. But um, you could probably, as terms of, you need to actually manually find the IQR so you know you're entering in the right value here. So I always need the numbers there. So I'm not sure. I'm not sure what else you're referring to. I'm a little confused. Oh, yeah. Well, that's a good point. And I'm going to tell you, actually, in this case. So I see what you mean. Okay. Now I see what you mean. So I am going to tell you here that that's not always true. Okay. I'm going to tell you here that is not always true. So, one of the things that you don't want to do is make the assumption that it's always going to go to the lowest value or the highest value. Now, why is that? I actually added a note just for that. And let's take a look at that note here, because that is a common misconception here. Is like, hey, when it comes to mathematics, I just don't assume. I said, okay, let's just go with the process here, because then if we just assume, then things could easily go awry. So I put this note here because it actually does acknowledge that point, and that says, let's say you had a data item here. So it says, let's say I had a data item here. Let's say there was an extra data item. Let's call that data item 87. Now, let's say that data item says, say any data items in the data set that are less than the lower outlier boundary or bigger than the upper outlier boundary can be marked with an X. Now, this is very important here. So again, if 87 existed, right, as a data item in the data set, I would put 87 out here in the middle of La La Land, wherever that happens to be on my number line, and I'd mark that specifically with an X. Now, the reason why I would do this specifically is 87 is above my upper outlier boundary, and this can happen here. All right, this can happen because in a data set, you could have very extreme values, whether it be a very low value or a very high value. Okay, it just depends at the end of the day on what data items that you have in that particular data set to begin with. All right. And so again, that's why the whisker can't be assumed to go out to the very largest value here. You need to actually look at the boundaries and then follow the rules that you have here in step 6 in order to draw it out to its the appropriate data item at the end of the day. And any data items that fall outside of that point, again, we just mark with an X. That's why we call it an outlier, because again, upper outlier boundary, lower outlier boundary. Again, those are outside of the bounds that we had found from before. So it can happen in data sets where we just have extreme values, for whatever reason, it just happens. Okay. It can happen, you know, sometimes you'll get a simple one like we have here, but sometimes you could get something that looks like this, okay, where you're just putting an X there, and that's fine. Okay. All right. Now, to go along with this here, we do have one more thing that we do need to discuss. Actually, a couple more things we need to discuss, and then I just need to keep you here a little extra time because I do have something important to announce. So give me a few more minutes here, guys. Okay, now we are going to talk about one more thing here, at least on this handout, and we're going to talk about here, number 8, which is talking about a 5-number summary. Now, a 5-number summary here is fairly simple. Okay, this just basically is exactly as it sounds, a summary of the data set in 5 numbers. Okay, so really not too hard when you kind of sit and think about it. It's actually pretty easy. But let's take a look at what those 5 numbers are. Again, I usually do the 5-number summary after I do everything in the box plot, because then it's easy to look at the numbers and find them. So the first one here is the low value here, the lowest value in the data set. All right, so the lowest value in the data set here is 3. Okay, you can look at the data set here. 3 is the lowest value in the data set. Simple enough. Next is Q1. Q1 you found in step 2. Again, that's 12.5. So again, there you go. That in 12.5. All right, easy peasy. Next is the median. Median here we found is 27.5. All right, pretty simple stuff. No problem. You can even use the box plot to find this. Q3, here we can just look at the box plot here. That's 35.5. So again, that's Q3. And then finally, the high number here, the largest value in the data set here, which happens to be 55. from our data set. So this is basically going to be our 5-number summary, just like so. Okay. All right. So that part there, not so hard. All right. All right. Before I make my announcement here, are there any questions? Does anybody have any questions over this part of chapter 3? Now, I will be showing here next time about how to put this on a calculator, guys, so I will be showing that for next time. I'm out of time here. But this is effectively the end of chapter 3, everybody. So, I do need to make a very important announcement here. Okay? This is actually one of those things that actually does have important meaning. Okay, so this is effectively the end of chapter 3. Now, because this is the end of chapter 3, I set a date for when the homework and the test for over chapters 1 through 3 will be due. Okay, because that's what the test is over the first 3 chapters here. So the homework, so I'm going to put this in chat here. The homework and test for chapters 1 through 3 will be due on this date here. Will be due in 2 weeks. Okay, so in 2 weeks, you should have all the homework and the test done. All right. So all the homework and all the tests, there, just that test should be done there. All right. Just to give you a heads up, the test, since it's your first test, again, how many questions? I got that question last class. There are 30 questions on this test. I'm giving you plenty of time to do it. Okay. You could take the practice test. The practice test, as was said the first day, is the actual test, just with extra resources. Okay, you get to help me solve this and all that stuff, and then I take those away for the real test. Again, you get 5 tries to get the best score you possibly can on the test. You don't have to take it 5 times, of course. And you get 10 hours of which to finish 30 questions. That should be plenty of time of which to do. Again, you do get bonus points if you try the practice test, so that's one thing that you should keep in mind. Make sure you get that homework done. That's worth quite a few points as well. So I've changed all the times there. Now, there's one other thing I need to discuss in regards to the test. So to give you a few more details, I put a setting on the test there, which is a save for later option. So here's how it works. Let's say you're doing the test, and let's say you're doing it late at night or whatever the case may be, and you're going to go do the test in order. So it'll go question by question in order. And let's say you're tired, you know what, you need to take a rest, and that's perfectly fine. So what you can do is you can answer that question. You can say you save it for later, you log out, and then you can come back and restart on the next question over. So let's say you do the first 10 questions, you can stop there and you just start on question 11 moving forward. Again, that does come with the caveat. All right, meaning to say, if you do decide to come back later and use the save for later option, you cannot retry questions that you have already done. So once you've done the save for later, you are locked out of those questions for that attempt, and you'll just need to keep moving forward from that point. Okay, so again, you will not be allowed to do any questions that you have attempted. So again, be sure that you answer up to the point that you wanted to, then you log out, you come back the next day, maybe refreshed and renewed, all right, and finish off the rest of the questions as you see fit. It's not too hard, okay, I can promise you that. This test here is pretty straightforward. Again, it will reflect the homework, and again, try the practice test. There's bonus points, and certainly everybody who tells me they tried the practice test said it immensely helped them get a really good score on their actual test, and that's exactly what it's designed to do. So, does anybody have any questions about the test or anything like that? Anybody have any questions? That's correct, Sanla. Now, I am just going to point this out here. Again, quizzes, homework can be found underneath the homework tab. Well, that's exactly what they're there for. So homework can be found under homework or assignments/assignments. And then tests are found under quizzes and tests. Okay. So you can find quizzes and tests. I think there's an ampersand in the middle. So sorry, it should have been like this. Now, one more thing I am going to say here is that I've given you plenty of time of which to finish, okay? I've given you 2 weeks from today. If you've been working at pace with the class, you should be pretty much easily be able to finish off the homework and then try the test out. So again, one of the things I'm going to tell you right here and right now is please do not ask for any extensions. All right? Not ask me for extensions. I've given you plenty of time to finish. It's 2 weeks from today. I could have made it 1 week, but I'm like, you know what? Let me give you an extra week of here to finish, so you have plenty of time which to finish. So there should be no excuses. You guys have it all ready to go, you know, and that should be that. By the end of these 2 weeks, that means we'll be in class for about a month. So it's like a month of having a chance to do the homeworks and stuff. I'm like, that should be plenty of time. All right. Okay, so that'll take care of it for today, everybody. I want to thank everybody here for coming on out here to the stream once again. All right, sorry for keeping you a little bit of extra time, but this was important for me to go ahead and say. All right, thank you again, everybody. I hope everybody has an absolutely fantastic weekend. You know, get going with the homework. Hopefully, again, get stuff done. We're gonna be moving on here to chapter 5 here for next time. That's what's on the docket. But we're gonna again, we'll come back on Tuesday, same time, same place. In the meantime, though, everybody enjoy a very nice and wonderful and relaxing weekend. Enjoy yourselves. All right. Love you all, you guys. All you guys are absolutely fantastic and amazing people. All right, and we will see you then. All right. All right, everybody. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Have a great one, everyone, and we will see you next time. All right. Take care, everybody. Have a great one. See ya. All right. Bye.